on Earth, most things are in the neutral state. Basically, the neutral state is when almost all electrons are tied to atoms. So the number that can move freely is very small, basically. We
But
can
if you
get into it another place, a more scientific definition, so that it becomes clear why metals are not plasmas. They're not. Um, but uh,
but you can actually model a metal as a degenerate electron gas at the end of the day.
right, but that's not the same thing. But when we talk about neutral substances, the fact is the atmosphere in this room, the wooden desk, you know, myself, all of these things are not plasmas. They are made up of overwhelmingly neutral uh, atoms to the point that free electrons are very, a very small proportion that are free to move in any direction. So, um, anyway, to get back to the story,
Oh, it's an interesting free to move in any direction is an interesting feature of that, right? Because like as you say, like the because I was like, well, inside of the body you can bound your system to like the electron transport chain of the mitochondria, where there's definitely like the flow of electrons, and they do seem to have some kind of degree of freedom, but they seem well channeled. Like it's more like a wire than it is just this space where they can move any direction that they want to. Like they're very
I mean, the
direct.
point, that, yeah, the difference between a current in a plasma and a current in a solid conductor is that in a solid conductor, the electrons are moving, but they're hopping from one atom to the next. So the difference is in a plasma, the electrons are for significant lengths of time disassociated, moving independently of the ion. And of
Yeah, it's
course,
all about lattices, right? Just depends whether
yeah.
there's a lattice where the
So
nuclei are frozen.
yeah, basically, I would say that that's a good layman's definition is that in a current in a solid, you've got electrons hopping from one atom to another, while in a plasma, they really are traveling by themselves, as it were.
Except
And
for the surface of the sun, right? Because you have this collisional scenario where the nuclei, their location is fixed by their collisions, and so you have something closer to the wire actually going on with the
no,
NHD.
but again, in the sun, you do not. Um, you have basically 100% ionization. In the sun, even at its surface, is 10,000 degrees. 10,000 degrees in electronic measure is approximately 1 electron volt. So by the time you reach 1 electron volt already, more than half of your hydrogen is ionized. And as you go deeper into the sun, temperature rises very rapidly, as it paradoxically does in the opposite direction as well. Um, and then you get almost 100% ionization. So, 100% ionization means that even though the electrons and the ions are always colliding with each other, they don't remain in association. You don't have electrons moving in steady orbits around the nuclei. So that's the quantum defined state of a neutral uh, atom. And with hydrogen, since it only has one electron, there's only two states. There's either total ionization or a totally neutral atom. And so basically, in a conductor, for example, in your body, the vast majority of the time, the electrons are tied in that quantum state inside the atoms, inside the molecules. And they're just briefly hopping. A small minority of them are hopping because the sort of currents that are within us, it's an absolutely, a trillionth of a trillionth of the electrons are actually carrying the current. But in the sun, basically the collisions are just collisions. They're collisions between two free particles, and the atoms never form. So that's a big difference. Tired of inflation, wars, and inequality caused by the energy crisis? LPPFusion is developing a solution that could allow everyone to have cheap, clean, off-grid, and sustainable fusion energy. Invest now as we seek to bring this potentially life-changing technology to market. For more information, visit WeFunder.com/LPPFusion.